All right, buckle up, everybody, because today we are driving into something truly mind-blowing. The idea that evolution isn't just about life. Like, it's actually built into the very fabric of the universe itself. You guys sent over some excerpts from this article called Can Matter Evolve Without Biology?
Neat.
And, wow, it is really making me rethink, like, everything I thought I knew about how the universe works.
Yeah.
So, the big question here is, how did we go from this chaotic soup of particles after the Big Bang to, well, the incredible complexity that we see today? Galaxies and stars and planets and even life itself. It seems impossible that it all just happened randomly.
Right.
Thankfully, we've got our expert here to help us unpack this truly mind-boggling concept.
Well, what's fascinating to me about all this is this concept of self-organization. It's this idea that simple interactions between particles can lead to these incredibly complex patterns, almost like a cosmic dance. But instead of fancy footwork, we're talking about fundamental forces like gravity. Gravity, despite being a simple force, acts as a sculptor on a cosmic scale. And over billions of years, its pull leads to the formation of galaxies and stars, really showcasing the power of this self-organization.
So this cosmic dance, it isn't just about pretty patterns. It actually determines what the universe is made of.
Exactly. And this process is inherently evolutionary, even without biology. So over, billions of years, stars are born, they live, they die, and then in their death throes, they scatter the elements that they've created, and it seeds the universe for the next generation of stars and planets. So it's this cycle of creation and destruction that drives the universe towards greater and greater complexity.
Okay, I'm starting to see how this self-organization thing works. But it still feels kind of counterintuitive. I mean, the universe is full of these incredibly complex structures that have nothing to do with life, right? Like snowflakes or river deltas. I mean, they're stunning, but there's no DNA or cells involved. So how does that happen?
Well, that's where non-biological self-organization comes in. Think about volcanoes. When lava cools, it crystallizes into those beautiful geometric shapes, all thanks to the way molecules interact as they lose heat and solidify. It's a reminder that complex patterns can emerge from simple physical and chemical processes, without the need for any blueprint or genetic code.
So even something as seemingly destructive as a volcano can create order and beauty.
Yeah.
That's almost poetic when you think about it.
Yeah.
Are there other examples of this kind of non-biological complexity?
Oh, absolutely. And they're everywhere. The fractal branching of river deltas, the mesmerizing ripples of sand dunes sculpted by the wind, even the way Earth's minerals diversified from simple compounds to over 5,000 varieties over millions of years. All of this happened through repeated heating and cooling and mixing. No DNA required. It really highlights this inherent creativity of the universe, even without life in the picture.
Wow, that's amazing. It's incredible to think that those same processes are happening on a cosmic scale too, right? I mean, space is full of mind-blowing structures and formations.
Exactly. And some of the most awe-inspiring examples of self-organization are actually found in space. Think about Saturn's rings, those mesmerizing bands of icy particles all dancing in perfect harmony thanks to gravity's pull. They're not just beautiful, they're a testament to the power of self-organization over millions of years.
Oh yeah, or the spiral arms of galaxies, those vast swirls of stars and gas. Are those shaped by self-organization too?
Absolutely. Spiral galaxies are shaped by something called gravitational resonance, which causes matter to clump together in these beautiful swirling patterns. And even black holes, those cosmic destroyers, play a role in this grand cosmic dance. They can trigger the formation of new stars by compressing gas clouds, showing us that even destruction can fuel creation in the universe. It's a never-ending cycle of change and evolution, all driven by the fundamental forces of nature.
Okay, all of this is incredibly fascinating. But I have to ask, doesn't this whole idea of self-organization kind of clash with the concept of entropy? Like the whole everything tends towards disorder thing?
Right.
How can the universe be getting more complex if everything is supposed to be falling apart?
That's a great question, and it's a common misconception about entropy. While it's true that the overall entropy of the universe is increasing, that doesn't mean that pockets of order and complexity can't emerge. The key is energy flow. When energy flows through a system, it can create these temporary pockets of decreased entropy, leading to the formation of complex structures.
So it's like a river carving a canyon, right? Like the water itself is flowing downhill, following the path of least resistance. But in doing so, it creates these incredibly intricate formations.
Exactly. And the same principle applies on a cosmic scale. Stars, for instance, burn their fuel and radiate energy into space. That energy flow drives the creation of heavier elements, planets, and potentially even life. Complexity thrives not in spite of entropy, but because of it. It's all about these energy gradients and the amazing things that happen when systems try to balance themselves out.
So the universe is constantly trying to reach a state of equilibrium. But in doing so, it creates all this incredible complexity along the way. That's pretty mind-blowing.
It really is. And this brings us to one of the biggest questions of all. How did this self-organizing principle eventually lead to life? How do we go from lifeless matter to something as complex and wondrous as a living organism?
Yeah, that's the million-dollar question. It seems like such a giant leap.
It is a giant leap. But it's important to remember that life doesn't break the rules of physics and chemistry. It utilizes them masterfully. To understand this transition, we need to look at the concept of chemical self-organization. Imagine the primordial Earth, with its oceans teeming with simple molecules, driven by energy from the sun and geothermal vents. These molecules are constantly colliding. Some combinations were more stable and more likely to replicate. And over vast stretches of time, this led to a gradual increase in molecular complexity. That's chemical self-organization in action.
So through all that chaos, some molecules managed to stabilize and replicate, eventually leading to the building blocks of life. It's amazing to think that something as complex as life could emerge from such humble beginnings.
Exactly. And one of the most fascinating examples of this is DNA, the molecule that carries the genetic instructions for life. It's a self-replicating molecule, shaped by the same forces that create snowflakes and crystals. But it has this incredible ability to store and transmit information.
It's like the universe, stumbled upon this incredible hack, using the laws of physics and chemistry to create a system that could, perpetuate itself. It almost feels like a magic trick.
Yeah.
But if we're talking about self-organization leading to complexity, what about human technology? Does that fit into this picture too?
That's a very interesting question, and one that leads to some thought-provoking possibilities. Think about the internet, for instance. Billions of interconnected nodes, constantly sharing information and evolving. It's not so different from a neural network in the brain, which is a biological system that exhibits self-organization.
So if self-organization is happening in technology, does that mean we're creating something that could eventually rival biological intelligence? Are we talking about artificial intelligence becoming like a major player in the universe's grand scheme?
That's certainly a possibility worth considering. After all, AI systems are designed to learn and adapt, much like biological organisms. And this leads us to some truly mind-blowing theories about the universe itself as an evolving entity. But we'll dive into those after a quick break.
Okay, sounds good.
All right, so before the break, we were talking about some pretty mind-blowing theories about the universe itself, evolving. And one of those is the cosmological natural selection model, which suggests that universe...
Okay, wait, hold on. Universe is reproducing. How could we ever even test that idea? Is this even science, or are we just drifting into the realm of speculation here?
It's definitely a highly speculative theory, but it is grounded in some intriguing ideas about, how black holes work and the nature of the Big Bang. So the basic idea is that each black hole could potentially give birth to a new universe, with each new universe having slightly different physical laws.
It's like Enjornis.
A cosmic version of natural selection, where universes are competing for survival, based on their ability to create black holes. The universes that are best at creating complexity would be the ones that, reproduce most successfully.
Exactly. And those universes would be more likely to have the conditions necessary for life to emerge. It's a mind-boggling concept, but it really highlights this idea that the universe might be far more dynamic and interconnected than we traditionally imagined.
Yeah, it's definitely making me rethink everything I thought I knew about the universe. But, what I'm finding really fascinating about all this is this idea that we're not just passive observers in all of this. We're actually part of this grand self-organizing system that's been unfolding for, billions of years.
That's a key point. We're not just witnessing this cosmic evolution. We're active participants in it. The fact that we're even having this conversation, pondering the nature of the universe and our place in it, is a testament to the incredible complexity that this self-organizing principle has produced. It's almost like the universe is, becoming aware of itself through us. Like our brains, our thoughts, our consciousness, it's all a product of this grand evolutionary process.
That's a profound thought, and it's one that's been explored by philosophers and scientists for centuries. If even lifeless matter can evolve into complex structures, what are the limits of possibility? Could we be the universe's way of becoming self-aware, of contemplating its own existence?
Whoa. That's getting pretty deep. But it's also incredibly inspiring, isn't it? It makes you realize that we're not just like insignificant specks in a vast and indifferent cosmos. We're part of something much larger, something that's still unfolding, something that's full of potential.
Exactly. And that potential isn't just about what the universe might become, but also about what we, as humans, might contribute to this ongoing process of evolution. We're not just inheritors of this incredible legacy of complexity, we're also its custodians, responsible for shaping its future.
So it's not just about understanding the universe. It's about shaping it, contributing to its evolution in a meaningful way. But how do we do that?
Through our creativity, our ingenuity, our ability to push the boundaries of knowledge and explore these new possibilities. Our art, our science, our technology, it's all part of this grand cosmic dance. Every new discovery, every new invention, every new idea is like a step forward in the universe's evolutionary journey.
So even our small actions can have ripple effects throughout the cosmos. That's an incredible thought. It means that even like seemingly insignificant things can contribute to the universe's evolution.
It's true. Think about the invention of the printing press. It revolutionized the way we share information.
Yeah.
And that had a profound impact on human history and culture. Who knows what the long-term consequences of that invention would be on a cosmic scale?
It's like we're planting seeds of complexity, seeds that might blossom into something incredible in the far future. And it's not just limited to like
physical inventions either, right?
No.
Our ideas, our values, our stories, they all have the potential to shape the universe in profound ways. Precisely. And that highlights this profound responsibility we have as humans. We have this incredible power to influence the course of evolution, both for ourselves and for the universe as a whole.
So it's not just about understanding where we came from, but also about where we're going and what role we want to play in this grand unfolding story of the universe. It's a lot to take in.
It is, but it's also incredibly exciting. It means that we're not just along for the ride, we're active co-creators, shaping the future, alongside the fundamental forces of nature. And who knows what incredible new forms of complexity might emerge as we continue to explore, experiment, and push the boundaries of what's possible.
This has been an absolutely mind-blowing conversation. I feel like I've gained a whole new perspective on the universe and our place within it. What an incredible deep dive.
I'm glad to hear that. It's always a joy to explore these big ideas and consider the vast possibilities that lie ahead.
So for our listeners out there who are feeling equally inspired, what's one key takeaway you'd want them to remember from this deep dive?
I think the most important thing to remember is that we're not just these isolated individuals living on this tiny planet in this, vast and indifferent universe. We're part of something much larger, something that's constantly evolving, something that's full of wonder and possibility.
Right.
And we actually have a role to play in shaping that future, both, individually and collectively.
I love that. So it's not just about understanding the universe. It's about participating in its evolution, contributing to its ongoing story.
Exactly. And the more we learn about the universe, the more we realize just how interconnected everything is. From the smallest particles to the largest galaxies, we're all part of this grand cosmic dance.
And who knows what incredible new steps we might learn along the way. Well, that's all the time we have for today's deep dive into whether matter can evolve without biology. But before we go, we want to leave you with one final thought-provoking question to ponder. If even lifeless matter can evolve, what are the limits of possibility? Could we be the universe becoming aware of itself? It's a question that's been debated by philosophers and scientists for centuries, and one that might not have a, definitive answer, But it's definitely a question that can spark our imaginations and inspire us to keep exploring the mysteries of the universe. We'd love to hear your thoughts on this, so feel free to share your insights on our social media channels. Until next time, keep exploring.